Okay, so I fell in love with the Arduinos because all the legwork is done. Somebody did it. And for the kids now we're doing high-end sensors that we weren't able to do before with Pick Basic because we had to do all the legwork. And I'm dealing with 9th to 12th grade students, and we don't always get the legwork done or right. Sometimes I have a couple of high flyers in the classroom. I say, Jimmy, can you look at this? Spend some time in a data sheet because that's where all the answers are. And if you come in new as a 9th or 10th grade student, I would say a data sheet in a semiconductor device. It's kind of like your birth certificate. It has all your information on there when you were born, how much you weighed, how long you were, and all that stuff. I said the data sheet's the same way. Anything in semiconductors has a data sheet. Resistors, data sheets. I never saw a data sheet for resistors. Sure. But in general, the microcontroller, this is 8 bits. So this only counts up to 255, which isn't that high. But to a high school kid, they can relate to 255. A 16-bit controller, which is much nicer, faster than an 8-bit. I don't have the number memorized off the top of my head. I think it's 65. Is it 32,000? You know, I forgot my calculator. I think a 16-bit will go to 32,000 something.
635, something like that.
30. Is it 32 or 65.5? I think it's 30 something. So it's 2 caret symbol 16. 2 caret symbol 16 minus 1. So I don't want to talk too much more because I want you to play with these things because these are addicting. But anyway, to make a long story short, Smitty, I got a few sensors on here. Here is the old-fashioned LM34. All that is a positive 5 volts ground. As you can see, the line going, one pin's going to red, the other pin's going to blue, the middle pin's going to the microcontroller. Now that chip, that IC is an analog voltage. So I have to go find, where is that going? Is that going to A0 on the controller? For some of you that can see that, is that going to A0? That line? I think it's what color do they use?
Red.
Red. Is that red going to A0?
Yeah.
A0 means that's an analog input. A0, A1, A2, A3, A4, and A5. Those are all analog inputs. If you have a program for analog.
A0, bottom, 4.
You see it going over to A0?
You need my glasses.
Okay.
Yeah, he's gonna need it.
So here is A0 right there. That's it right there. Here's A1, A2, A3, A4, A5.
In the middle pin.
You got it?
Yeah, he's just using the 5 volts to put it on analog and input 0.
So here is A0, A1, A2, A3, A4, A5.
Probably gonna see
This red line is going to A0. That's analog in 0. Okay? Okay, so now what we're going to do is I downloaded the software. Jimmy.
When you're done, you can fix mine too.
Yeah, which I'm not.
Okay, so
this could be smoking.
What you're going to do here is go to January. I put and LM34. Double click on LM34 and it should bring you up in Arduino. So
You got that thing? No. Go to January.
Shit.
No, I don't have some stuff installed there. In January.
I said my I did the same thing you did.
Okay. So come over here to January. Double click on January. Come to January.
January.
Double click on LM34. So I downloaded January. So what you're going to do is you're going to connect this up to your, and we're going to backfeed the computer power into it. No, it doesn't matter. Well, it will, because we're gonna have to tell.
Yeah, sure.
Which port
This
we're
is
using.
set up,
Open
yeah.
it. Yeah, double
You can
click
use this computer.
LM34, double click, and it should bring up Arduino. So yours is running, is your?
No, you didn't put the software in.
Yeah, put it in there.
I did.
Go down here. Over here to amateur radio. Wow. Like that. Like that. Come down here to Tech Night. You got to double click on that.
You want me to open that?
Yeah. Come down here to Tech Night. Double click. January. Copy that. Put it on your desktop.
Go through something, no?
Right, so that's what you want to see.
Yeah. Is that copy now on there?
Yeah.
Okay. Delete that. Exit that. And let me get that online for Jimmy.
Must have been that. I turned it off because my Kenwood running as your computer.
You up and running? It?
No, I lost my thing, so I'm gonna just make it simple.
All right, then I'm gonna put this underneath.
Yep, go ahead. Take the whole thing.
Okay, so let me share my screen here. Are you there, Jimmy? Connecting with audio. Okay, so how do I, let's see, how do I share here? Share screen. Share screen. Amateur radio. Tech Night. Okay, so let's talk about this, because I'm going to be honest with you. This could get a little bit dicey because, quite frankly,
Wait, Tom, I think you gotta select what screen you want to share.
am I not doing that?
No, I think you got the wrong tab. So go back down to. Yeah, click that again.
Like this?
Yep. Well, stop share. Right there in red. Stop share. Now go back to share again.
Share?
Now you see how it,
Or this one?
click that. Now you see how it opens all those windows?
Yeah.
You're gonna pick the one you want.
Oh, so it would be this one.
Right. Right.
Okay, so now I'll be right there.
So we're going to LM34.
LM34. Okay, give it some time. I'm hoping everything is okay. If not, I brought another laptop. But that's it worked.
No, it's still spinning too.
Right.
That's how it's probably not faster.
I think so.
Yeah, mine's coming up.
Wonderful. That's our computers for LCTI. Okay, so let's talk about this. So I stole this from I get a lot of stuff from this guy here. So randomnerdstutorials.com. This is where this software came from. Okay, so again, somebody did the legwork, and what I usually have the kids do is we'll put our stuff on it, maybe update it a little bit. Now, I did not bring any displays with me because all the kids are using them. This display here, you can get on Amazon for maybe 6 of them, 5, 6, 7 of them for maybe under $20 for all of them. But the only problem is these are like 1 inch by 1 inch. Okay, you got your ground, your VCC, your serial clock, and serial data. See, this is the old-fashioned Arduino, which I wanted to get away from with the kids because I wanted to put our stuff here and run wires right on the board. Because, you know, I run an AM and a PM class, and the AM might take this off and put it over here for the kid in PM. And they're wasting my time trying to troubleshoot this circuit when that's a mess. So I don't want to do that. Here's the sensor right here. You have positive voltage, your actual voltage signal, and ground. And he's running it back to the A0 here. So that's this. If you scroll up a little bit, again, I have, so this is going to work for an LM35, which is the Celsius temperature sensor, the LM335, which is Kelvin, and the LM34, which is my favorite, that's the Fahrenheit temperature sensor. So this sensor, by the way, that LM34 on DigiKey is about $6. I used to get them for $3. That's how much the prices have gone up from circuits. But anyway, yeah. Here, this is how nice this guy is. I mean, he's got it all in black and white. The nice thing about these LM34s and 35s, when you turn this thing on, this is measuring the air temperature right off the bat. And this voltage right here is a DC voltage in millivolts. That is the temperature that it's reading. So this is a Celsius. I don't get Celsius. Fahrenheit, the room in here, what's the temperature, Bill? Behind you, 70? Yeah. So I would guess this LM34 is going to measure about 71, 72. It'll be about 710 millivolts on that line by the digital multimeter. That's why I love those LM34s, because you don't really even need a microcontroller. You can just hook up a digital multimeter, the red lead on the V out and the black lead on ground, and that digital multimeter will say 0.719. It's 71.9 degrees in it. That's what that thing would be picking up. So I went super easy. There's the LM335. I don't get into that. I never played with the 335, but the simple circuit right there. The LM34 and 35, middle lead the A0, red lead the positive, black lead the ground. And if you don't know anything about these breadboards, where you have a red line here, it's shorted this way. You have a blue line, these are all shorted this way. This group of 5 right here, 1, 2, 3, 4, 5, they're only shorted right here. These 5 are only shorted right here. Okay, there's a trough right here in the middle. Then you have another group of 5. These are only shorted to themselves also. So if you want this 5 here shorted to this 5, you need to run a jumper wire into there so that you have these 4 pins and those 4 pins to use for that same common point. So breadboards, takes about 3 days to go over that with freshmen. That's. I tell them if they understand how to use the breadboard and schematics, symbols, they can build anything. So anyway, I got locked out again. All right. So Random Nerds tutorial is a very good website for a lot of free stuff. So now I'll scroll down. Now, this here's the code. Okay, so there's the guy who put the code together, Raul Santos. All right, so here's what he's doing. Constant input, constant interrupt, sensor pin A0. So there's where he identifies what pin we're going in. If I want to change that to A1, A2, A3, A4, A5, that's where I'm changing it right there. One thing I got to get used to is the semicolon practically after every one of these lines. Because if you don't put them in there, Arduino has a fit. And I'm still learning that because this is our first year working with Arduino. Float, oh, this is nice. Float, that's a variable, but the nice thing with float is it's possible to use a decimal point with Arduino. Basic, you can't use a decimal. You have to manipulate it in the LCD display to put the decimal This is a nice feature. So we're going to sensor value. We're going to make that a variable. A voltage output, that's a variable. Temperature C variable and temperature F variable. Now, it took me a little bit of time here. Uncomment if using an LM335. That means you would delete these two here, and you're going to float temperature Kelvin. I'm not using a 335, so I got to leave that alone. Void setup. So setup. This is what you're going to run this once. Pin mode, sensor mode, input. So it's looking for a value on our input A0. This is a nice feature. The reason I didn't bring displays today is because your laptop is a display. This serial out will send the data from that sensor to your laptop, and you'll see it on the laptop. Tech Basic doesn't do that. That's nice. That's why I didn't bring any displays. Okay, so loop here. This is going to run continuously. Sensor value, analog read. That's your analog voltage. Voltage out. Here's where he's doing some math. Now, calculate temperature for LM335. So here's where he's doing the temperature range for the 335, and then he's going to do the math conversion for the Fahrenheit. Let me scroll down here. Okay, so now, if you wanted to uncomment, this is what we're going to uncomment here. We're going to uncomment this, and we're going to uncomment that. And we're going to use this information here and here, and then we're going to send that out serially to the computer to give us the temperature from that sensor. So maybe you can do it because you don't have a school laptop.
So we want to verify it first, or?
Well, okay, so good question. So when you're in the program, okay, so this is an old program. Bear with me. The IDE is the brand new one. You know what? Here's a program. Real quick, FFT, radar, fast Fourier transform. This is high end. This is what we use for that, the more expensive ESP30, the better quality ESP32. FFT is how the radar guns work. What happens is the beam goes out, there's a frequency when it comes back. That frequency is what the FFT program is looking for. PIC doesn't have that, but there's a library for FFT. We have a radar gun in school, and I bought one of those Bushnell guns to see if we're close. Not bad, not bad. That's a ESP32. That works very well. Let me take care of business here. Hold on, folks. Oh. You see this down here in the bottom right? You see it says updates are available for your libraries. That means somebody's gone out there and said, hey, you know what? I made a mistake. The calculation's a little off. They update the libraries all the time. Jimmy Moyer makes a library, and he's finding out that his lux sensor is a little off compared to what the calibrated one is. So he's going to go out. Oh yeah, right there it is. I got to change the math a little bit. So then they'll update the sensor to the libraries. The libraries is where all the work is done. We wouldn't do that. So I'll do that. So it's going out and looking for some stuff here and fixing some items right here. All right, so let me, this guy here is called the Arduino Nano. I gotta eject this. Hold on.
Was it a nano or mini?
It's the Nano. If it's, these are not real Arduino products. Arduino is open source. So Adafruit made this. They call it the Mini, but if you look at, it's the Arduino Nano. Jimmy, are you there? I mean, do I hear anybody? I don't hear anybody.
I'm here. Do you hear me?
Oh yeah, we got you.
I'm not missing the darn thing here, I'll tell you.
All right, hang on. Okay, so I got this. Okay, I think this is opening up my old, this is opening up the old one. Arduino calls it a sketch. We're going to go to a new sketch. Control V. Okay, so there's the software. Oh. All right, let me eject this because I only have 2 USB ports on my laptop. Well, this could be a disaster. Okay, so it's up here. Up here is the Nano. Okay, and we're gonna hopefully this is gonna work. If you don't know what board you have, or if it doesn't come over here, type in NANO, and it should say Arduino Nano. Double click, and the USB 5. I'm hoping this is gonna work. Okay, so then after you have the board and the port, this is the verify. This will just go through the program. If there's any mistakes, it will not upload to the microcontroller. Okay, so it went through it. I didn't uncomment these, so I'm gonna have to do that. But to program it, then I would do this, and now it would be, as you can see, it would be updating. And once it's updated, right now, it's not going to work because I don't have the 34 in there. Give me a second. So I would come over here to Tools and Serial Monitor. And here's where the temperature would be right there. So here it's telling me 21.56 Celsius. It's 70.8 degrees Fahrenheit off that sensor right now. The actual millivolts is 708.01. Let's see, do I have that uncommented? Oh yeah, there it is. It is uncommented right there. I am using that right there. So that's the sensor right now. If I put my fingers across the sensor, pinch it, the temperature should go up, 74, 77, 79, 81. I let it go. It should come back down. So right now what we're doing is you're measuring across that. Let me see if I get these. Did it come up and work? Did it work?
I didn't screen the screen logged out.
Did it keep going around the circle?
Yeah.
Yeah, see that? This is I didn't know if you, this is the wonderful IT department. If I was not allowed on that, let me see.
Are you sure you don't have to be on the internet for it?
I logged in prior to the school, taking them out of the school.
What's the login?
And
I don't know. I brought my own laptop.
Oh,
Tom's
He has
Yeah, it's
used
reading it. It's reading.
I don't think it's gonna work.
Temperature.
I apologize.
So, you know, it's saying, hey, I'm not supposed to, am I supposed to be?
Yeah, that's exactly, because I'm not. I
Oh,
wasn't-
laptop?
Yeah. I have, you know, certain ones, let me see here, hold on.
Well, that's what I'm saying. Maybe if you're on the internet, like,
Let me see.
because I'll host to my phone if I have to.
Well, are you saying that it won't work if it's not on the internet?
I know.
See, mine's running.
He's thinking that,
See, mine's running and it's on the internet. Let me shut my internet off and try
but
it.
Frank, but he's saying, he's thinking that the computers are smart enough to say, hey, somebody took us out of the school.
see.
We're we're supposed to be, so we're not gonna work.
Yeah, it's possible.
It's also possible that I was signed in on that, program.
In other words,
Well,
you just yanked my Alpine stereo out of my car. Now it's not gonna work no more.
Oh, that's pretty small.
Let me see. That's zero.
Yeah, that little antenna is surprisingly good for what it is. I usually only use it around the house, but I mean, I can hit. Bear said that I can go online from my house with that little thing. Yeah.
See, it's our lovely attitude.
Yeah, I am the basic principle.
Yeah, what's your password? Right. I can't even.
What?
They,
You could use.
I can't download the free software. I gotta call IT to ensure.
Right.
This pin.
Right.
All these pins are negative. So you could jump them. You see like this here.
Okay, so I don't want, it's already 7:30, I got a couple more cents to talk about.
Here, so that's-
Okay, so let's get to, as you can see, every time it's going out, it's coughing up some data with that orange LED flash. Okay, so is yours working?
Yes.
All right, so you got, that's a Fahrenheit temperature sensor. The LM35 would be Celsius. So it works pretty good. The kids get bored with it after a while because, well, anything else we could do with this missile. So I said, that's it. I mean, we could do some math to convert back to Celsius. But so this one doesn't last long. I tell them it's kind of like a potentiometer. The potentiometer varies between 0 and 5 volts. Right now, it's sitting at point. If you had a digital multimeter on it, it'd be about 0.71 volts on the digital multimeter, and that's basically it. So then I'll say, okay, let's try something else. Let's go and try this sensor. Let's do the Lux, because this was pretty cool.
So Tom, all these little pieces of software, like looking at this one here to show you the temperature.
Yeah.
Like, can you mix and match the temperature?
You can do some stuff.
You need to be on the internet.
I tied it to my phone and it's working now.
Wow. All right, awesome.
Just don't see lights.
Police department has been notified and we'll be hearing about the.
Cool. So this serial print means we're going to be using this guy right here, the temperature C, and then here's the data for the temperature C. And then here's serial print temperature F. Here's the data for temperature F. And then here's voltage millivolts. That's this stuff here. And then there's the actual data for the millivolts. We can print this to an OLED display. There's some more software involved, but that's free online too.
So what you just do, like say you want to display Kelvin, you just insert.
What if I were to do Kelvin?
Temperature Kelvin. You would remove the flashes and it would then calculate.
Yes.
672.
So what you would do here is we'd have to take this off, double bar. As you can see, it went green.
Can't you run both sides?
No. The reason is because both of them are attached to A0. Both are at the same A0 pin. Okay, so that won't. You'll have to do another item for A1 if you want to run Kelvin. Unless there's the math for Kelvin. Oh, wait. Here, right there's the math. Right here it is. uncomment this, this, and this. There's Kelvin, there's the temperature for Celsius. So yeah, if I had 335, you could do all three.
And you would do a print.
Here, let me uncomment.
Oh, yeah, you
I
have
think you
serial
accidentally
print.
deleted- I think you accidentally deleted some code.
Okay, Control Z.
Did you do degrees ranking, Tom, too?
Okay, so that I'm not familiar with, Jimmy. Okay, so what is it telling me? Here's the error, compilation error. Temperature K, I wonder if that was not recognized up at the top here.
Well, your serial print isn't looking for temperature K. Right?
Okay, then we would have to add serial print temperature K. We would have to add that down there, but I don't think it's also yeah, see it's not up top there. So that we would have to put float temperature K. And then we would have to do float.
You stick comments after your instruction lines, Tom.
I tell the kids to try to do that because then you'll understand what's going on. Because this is where they need to put the comments afterwards and talk about this is where we go out for temperature C, this is where we go out for, this is temperature F, this is temperature K.
Actually, yeah, they already had it line 15.
Okay, so we're good there? No, float temperature K, right there it is.
Yep.
There's where I missed it. So I'm going to get rid of this. Go on. I'll come down here. Now I'm thinking it should work. Okay, the problem here though is it's not going to do temperature Kelvin here because it's not set up for serial print Kelvin. Okay, so if we would do some work there, then we should be okay. Okay, so and it, like I said, there's so much free stuff out there that you know, you could probably find this and do a little bit of homework on it and legwork, and you should be all right. Here, let me get to something, some other stuff here, because the kids usually, what I'll have them do is I bought a lux meter from DigiKey. I think it was like $285, and it came certified for 1 year. It was accurate. So I said, okay, let's put the certified meter next to the ours, and let's see how far we're off. I'll tell you, they're not too bad. They're pretty close.
Oh, the box behind you, put the lid back on and put it over there, just where you want to bend over, you'll be able to type off, put that in top of that box.
Where?
Right behind you. Put the lid on it.
Oh,
Put the lid on it, and then
I see.
and that way you won't have to bend over so much. Put the lid on it and work on the top of that. Which phone is it?
That's an Arduino Nano.
Help you a little better?
Yep. Okay, so now what I want to do is So this sensor here, I think Okay, it looks like I got a corrupt, it's corrupt. So what I'll do is I'll go out here and let me see if they have, I don't know if he has VE. I think it's a VEML 7700. Okay, so then what I need to do is, then I gotta go out here.
Come, how do you stop this from running, once you have it running?
Where?
Let's see how it's running up here.
Right here. Right there, push that. That should be it.
Okay. Temperature K, let's see if it works.
Get that signal from that thing. Back to your house.
You can get one of the ESP32s. now.
Okay, so now what I'll do is if I have a brand new sensor that I don't have data for or any kind of software, VEML, I think it's VEML 7700, and then space Arduino. My favorite vendor here, Arduino, Adafruit. Let's see if they have something. Okay, so here it is here. So let me download the file. This is the old software. This is 1.8 up in the top right left hand side there, 1.8.19. I don't like this. This is the old stuff. I like the newer one. So what I'll do is I'll just copy this. I'd like to talk about this real quick. Let me go to a new sketch, file, new sketch, which is another program. And let's control V. All right, so let me talk a little bit about this and what's important about this. Up at the top there, you see that it says include Adafruit. This is a library. That's a library that Lenore, I think she's the owner of this. She is the one who made that library for this sensor. I saw that data sheet, and I'll tell you, that is pretty intense, that data sheet. For something like a little Lux sensor, it's up there. So that's a library. Yeah. How do you get that? You go up to tools. So you go to tools. You come down here to excuse me, sketch, include library. And then you come up here to manage libraries. And then right here on the left side where it says filter your search, you could type in VEML 7700, enter. And as you can see, this is a library here. You would scroll down and see what else. DF Robot made one. This is the one that's probably that one right there. Okay, let's see if it gives me any errors. If it gives me an error, then I may have to install that manually. Yeah, see, right off the bat, it's saying include Adafruit VEM. This here, it does not understand that. So I'm going to have to go and install that. Again, it's free of charge. Piece of cake. This would probably take me days. I usually do install all. So now it's going out and installing that library, and we should be okay for that. Let's see if I can do it again. Fingers crossed. Okay, compiled. Compiling, all that means is taking this information here and changing it into a hex code. And then when we write, then we're sending the data to the controller in hex. Let me get rid of this. What?
Push your table up against the chair more. This way you don't have to worry about it. Give you a little more gap.
I'm worried about that thing I'm gonna break off. Okay, so here we go. Let me send it. Let's see what happens. Now we should be talking to that VEML. Okay, so we got an error. Oh, I know what the problem is. We got to go up and tell it what port. A lot of times it knocks me out. Port. Yeah, see, COM5 isn't highlighted. So I got to go out to COM5. Now it should work. That's it. So let me close this library here. And let me go to tools. And let me come down here to serial monitor. You see what's going on here? I got combo jumbo. See this? It's not working. The reason it's not working is I gotta find here serial begin, the baud rate on how fast this here is sending data to the computer. They have to be matched. This is at a 115/200. Here I'm at 9600. So I need to change that 9600 to 115/200. Scroll down. Now it should load up. There you go. So now this, the raw light value is what the sensor's seeing. The lux is 380.62. The ALS is other lighting that we cannot see that the sensor's seeing. I have to look that up because I don't remember which one. Is this seeing all the visible light, the sensor? We can only see a certain spectrum. I don't remember exactly what this and this were. That's the number right there that our meter would say about 390, 400, and we're measuring 380. So if I was to take my hand and put over the meter, the sensor here, you can see that going down. Then,
What does lux measure then?
that measures the amount of luminance of light in the room. Okay?
Where is it? Where is it, Tom?
What's that?
Can't see it. All
Oh, it's 379, 380, 3.
right.
I was gonna say.
So now put a light on it and I'll watch what happens. So now you can see it going up. The white light is 4,000 or 5,000, 3, 4, 5,000.
Gotta calibrate that. Jim.
Huh?
Gotta calibrate that chip.
Yeah.
So I'm telling you how fancy this is. We can actually change. We can actually change the sensitivity. Here's where Jimmy Moyer comes into play. Let me see here. So here's optional, and this is what that sensor says in that data sheet. You know, you can change the gain, and you can change how much time the sensor's on for the lighting. So here's the gain, and the integration time is set for 100 milliseconds at 1/8. So if I was going to change, we would have to put in here is some items here. Serial print 1 second, the gain of 1, the gain of 2, the gain of 1/4. That could all be, you know, played around with to get the actual value closer to a calibrated meter. I would say this is a little off. It's a little low. I would say it's probably around 390 in here, maybe if I had that brought that other meter in. But that's pretty cool because that would have taken us a long time to come up with, and we might not even have. We might be able to read and pick basic just this value. Okay, we wouldn't be able to get those without going to other rooms to figure out where that data is at. So this is good stuff. I mean, in education wise, somebody's doing the legwork, and it's a lot easier for anybody to do this. Now let's get to the better sensor. This sensor here, the BME 280. That BME 280, that's a temperature, humidity, pressure, and I believe it has altitude. Now the altitude is a guesstimate. What's the altitude of Tomaco? Does anybody know?
Change.
I'm at 924.
We should be under 14.8.
8 by 8. I think we're about 800 feet here. I think Tomaco, right, not you. I'm talking about this Broad Street, about 800 feet.
Yeah.
818 feet.
See that?
There you go.
Okay, so let's see how close we are. So what I'm going to do is I'm going to go back to my random. I'm going to go back to my random nerds.
Only 10.
You're taller.
It was 840.
The floor is not right.
You're taller.
You're standing, I'm sitting.
Okay, so random nerds. Let's see if this is it here. Yeah, this is it. So Arduino, and let me see, where's the. Let me just do BME 280 random nerds. There it is. Okay, so here it is. He's running off on our ESP32. Okay, so what he's using here, I bought these from Palolu, which is a different vendor. So this is the actual sensor right there. It's surface mounted, 1, 2, 3, 4, 8 pins, and V in, ground, serial clock, serial data. Now something you need to know about the Arduinos. A5 is generally the serial clock. That's a default serial clock, and A4 is serial data. So I piggyback the BME 280 and the VEML 7700 serial clock and serial data. So let me see if I can come down here and copy this. That little square metal piece is the actual sensor, and it basically very little parts. Let me get the. There's the software.
Where'd you get that code done?
Which one?
Oh,
random. Okay, random nerds tutorial. So all I did, Jimmy, was this. All I did was I typed in BME, because that's the sensor, BME 280, that's the name of the sensor, Arduino. And the nice thing is, here it is, random nerds tutorial. He made it. He made a copy of it. So then I'm using his website, and then I'm going to go and copy. And the nice thing is, he goes through every line, and he tells you what you need to install. So after he goes through this, and he tells you what he's doing. We're going to be using not SPI communications, but I2C communications. He's telling you that you're going to need wire.h. Wire.h is the I2C protocol. Adafruit sensor h.h is a hex file. and the BME.exe. So these are the 3 files that have to be libraries that have to be downloaded to this sensor before this circuit can work, and those are free of charge. You just have to know where to find them, and it's in the software. Okay, so let me get this done because it's already 8 o'clock, and I didn't want to go past 8 o'clock too much.
This is showing the results of meters. You've got to put a calculation.
Okay, so let me copy this.
Oh, right here.
Okay, so I don't have these files. So what he has here is he's prepping for STI.h if we needed that also. So we don't really need that one. We just need the wire.h, the Adafruit sensor, and the 280. So real quick, let me see. What is it saying? I don't have the, so I got to go BME. I'm going to go to Sketch, add file. No, include library. My bad, include library. Type in Adafruit, BME 280. There it is right there. See, it says install all. So that should take care of the BME 280. And let's see if I have anything else that I need. Oh, I do need something. Failing to upload. That's because I didn't tell it the port 5. I didn't click on port 5. Okay, so we're just going to basically go up to tools then and upload it. It's done. Let's see, serial monitor. And I got to go back to what's the speed of this?
9600.
Yeah, I'm at the wrong speed here. I'm over here. Now it should come up. Let me hit the reset button. There it comes. Oh, let's see. Check wiring. Could not find valid BME 280. So it can't find the sensor. That's amazing because I'm using the same. That's do I have
convert meters to feet.
Google. Something like that.
3.37. No, 3 feet. 3.281. 3.28. Tools, serial monitor.
Oh, I know where it is. I think it's this here. I gotta put the sensor address in. I think what does this say here? What does that say there in the backside? What does that say? 77, 76, 80. What does it say? What's the first one on the left?
0x76.
Okay, so
0x77.
I got to put in 0x77. I don't know if that's the address to the house. It's either that or 76. Okay, let me change that to 76. Okay, there we go. So the temperature right now is 20.8 Celsius. The barometric pressure is 978.31 HPA. Approximately, what's 295 meters? And humidity is about
295
34.
was 967.
So it's telling us about 967 feet here,
That's all.
which I think it's about 167 feet off.
Yeah.
Okay, so the the humidity in the room right now is 34.18%, 34.12.
What's the humidity now?
No, he's not looking at our thing.
Oh, which one's he looking at? This one.
That'd be real good. You read on mine, it registers on his.
67%.
68. Let's back it down.
Yeah.
That's pretty much all I have. I
So
mean,
Tom,
I
like with those,
want to cut it off at 8, but go ahead.
Tom, like with this temperature sensor we were playing with before
Yeah,
and holding it to make the temperature go up.
Yeah.
I know you talked to me on the phone about like LED lights, right? So I guess you could program it, if you had a light here, you know, let's say the temperature in the room was 70, if you held it, once it got over 80 degrees, the light.
that's
I
correct.
guess you just pop the light on.
Yes.
Do other stuff.
You could say in the software, if such and such gets this value, then output on D0 a high, which the LED would come on and say it's too hot. I did use his idea with putting that sensor in the refrigerator on a board like this, same microcontroller, and I had a display, a little 1-inch display. And I'll tell you what, the freezer was -3 degrees and the refrigerator was 41. I moved the sensor from the freezer to the refrigerator. And I was impressed.
That's actually my next project. I just got a deep freeze and I'm gonna use one to
I
monitor.
would not use an LM34. A DS18S20 from Dallas Semiconductor.
What was that again?
DS1820. That's discontinued. I think the new one is a DSB1820. Go to digikey.com. DS for Dallas Semiconductor, 18S20, I think is the latest one. DS18S20. It's either that or DSB20.
High precision one wire digital for.
Yes, that is the catch now.
Nice.
That's pretty much all I have. Anybody else have anybody online? You guys have any questions?
Watch before you sit down now.
Nothing? All right, well, I mean, that's all I have for the tech guys. Does anybody have anything else they want to bring up? Welcome to it. Sorry I didn't have those working. I thought they would. I'm not sure if I did this. I am missing a metal pin.
Oh my God, $14, man.
Yeah, they're
Expensive.
yeah. So that's it.
It's only $5 if I buy 1,000 of them.
Well, each.
$5 each.
Oh, well. All righty. I'm going to shut her down. Anybody have any questions online? Is anybody online to hear me? Jimmy, did you fall asleep?
Did you turn?
Yeah, shut it down. Smitty, help me out here. I'm missing this. I'm missing this here. That flew off. That flew off.
What's it, a clip?
Yeah. It's this here, Smitty. See if you can help me out there.
Everything's in that.
I have no idea where that flung.
Tom, can you hear me?
Yeah.
I've been here.
I know, I see you in there, Jimmy. You and another guy there. Thank you, Tom.
Tom, you'll have to send out a little email like this with a part list of some stuff.
Sure.
You know, it's interesting to.
And the thing, if you go to Adafruit, ADA, or you got offline, go to
No,
ADA FRUIT. Go to ADA FRUIT. That's where I've been getting a lot of my built-in sensors. Lenore is very good. ADA FRUIT. Now, you go to products, go to Arduino.
Saturday morning.
So the first thing you're going to need is, this is her version of the original Arduino. I didn't buy it. Scroll down. This is her version.
Yeah.
Okay, that,
The reason I have it there is I have my solar panels.
that's hers. And I think the original Arduino is like $24. That's her price.
What sensor?
Scroll.
Try to get my well pump
So-
in there.
Keep going.
Yeah. Yeah, what
Keep
sensor
going.
are you, what are you
Let me
using?
see which one I have.
What
Keep going.
background software program? Or you build stuff?
No, this one I got off.
A little further.
Amazon for about 20.
It's just Metro. See, that's, I have there,
Yeah, that's my.
1450. That's what you have right there. You'll have to solder on those pins.
This, multi.
Oh, so they fit into the board.
Yes. Okay. That's a
Oh,
must. Okay, that's the first thing you're gonna need.
How much is that?
Okay.
Yeah, this will alarm me if the freezer goes too high.
So that's this,
And this
and
is
you
the
have
one
to
in the
solder
kitchen.
these pins on. Then you're gonna need a USB-B to USB-A to program that.
Of course, it
A
has
small
that
bread.
airflow coming in.
You let me know what you need, I can
That's
loan it to
swinging
you.
like-
Yeah, that's okay. I'll pick it up to play around with.
Yeah,
It's pretty neat.
this one, see this one.
Temperature, look up, go back to the top here, type in BME 680. That's it. BME 680.
Oh, yeah.
It was -25
And where was that?
in our garage by the garage door. We had that
Oh,
little
That's
snap pressure like
that's a nice.
Yeah.
sensor.
Right.
Another sensor is an SCN41. That's a $50 sensor, but that tells you the carbon dioxide, carbon dioxide in the air, not monoxide, dioxide, which should be less than 1,000. in the house. If it's 1,000 or more, venture home.
And you had to go somewhere along the line.
Well, you can tweak this, you can tweak the gas.
Jimmy, I'm gonna say goodnight to you.
Thank you. I enjoyed it. I picked a few things up there. Thanks again.
Hey, we did tape it, so I don't know if it'll allow me to upload it, but we did tape it, so I'll talk to you later. Good night.
Was that it?
Well, you know what I want to do? One of these program, I know where it goes. Moisture sensor.
Right.
It tells us if this is an overflow.
Where about?